Dr. Alan, and good evening to our participants. Professor Alan is a research professor in the Division of Atmospheric Science, Desert Research Institute, Renewable. And he is the former Vice President of Research and Senior Director of DRI Clean Technologies and Renewable Energy Center. His research includes both laboratory and field studies of atmospheric chemistry, with the particulate matter emphasis on the impact of mobile sources on the environment. In addition, he has investigated discrepancies between observed and predicted automotive emission factors. His current research includes the measurement and characterization of emission from mobile sources operating on traditional biofuel and HCNG blended. And he is working on that new methods to develop PM estimations. And he has carried out many research projects funded by NREL, World Bank, and NREL World Bank. And he has occupied many seats. He is the former Vice President of DRI, and he is the director of that Renewable University, and he is a member of Sigma X, and he has received many awards and honors. So he has received Lady Davis Fellow Award, and he is the Best Researchers Award received from the higher education, and he has got outstanding faculty fellowship. He has received many fellowships. These are the some awards I have cited. Now I invite Dr. Alan to present his. Now I invite Mr. Alan to deliver a lecture. Thank you, sir.
Well, thank you. Thank you for the very kind introduction. And I guess by way of a little more background, I guess, we first met, I was actually working over in India, I think, when you contacted me years and years ago. And that was on a World Bank project looking at the sources of pollutants that were contributing to poor air quality in Hyderabad. So, yes. We've known each other for a number of years. So today I'd like to give you a presentation on energy trends, future scenarios over here, and their implications for climate change. And what we'll see here when as I talk about this is so much of the pollution, the pollutant issues that we talk about really deal with our need for energy. So how do we address that? But also, it's not just, often when we talk about these things, we talk about them being separate. We think of energy over here, water over here, climate change over here. The reality is they're all linked. And that's really going to be the major issue that I hope to get across as part of this presentation, is that nexus between energy, climate, pollution, water needs. And then by looking at renewable energy and the status of various renewable energy systems, what does that mean in terms of the prospects for addressing climate change? What does that mean for improving air quality? What are the implications of all of these changes? And how can we possibly get there? So that's really what I'm going to be talking about in this presentation. And I'm a little unsure of the whole platform that we have here. I can see some of you, but not all of you. I think I can see the chat, I think, if it does come up. So if you have questions, please don't hesitate. You can ask me in the middle. You don't have to wait till the very end. We'll make this more of an interactive presentation as best we can over here during these days of doing things using, Google Meet or Zoom or whatever. So, okay. So the first issue is energy security. Because one of the things that we can't deny is we all need energy. And as soon as you start looking at public policies that are going to reduce energy it's often difficult to get those through the political system. You know, clearly what you see here in this graph is you see that, you know, we've had a significant increase in our need for energy and a significant future projection for our energy needs. Much of that growth is in Asia. Much of that is due to the need in both China and India over there. That's where we're seeing an awful lot of that growth in our need for energy. But it's, you know, it's clearly needed, especially as we look for economic development over here. So, you know, one of the lessons that I've learned in my career is we have science on one side and we have policy. So how do we have science that can inform the policy without, you know, turning off the politicians? How do we make things happen? So I think first thing we have to acknowledge is we need energy. The second issue, of course, is climate change. You know, unfortunately, I think the world has come around to the fact that climate change is real. I know this is probably more of an issue in the United States. Even in the United States now, we're talking about, you know, on the conservative side, they're talking about climate change being real and they're not denying it. But it's unequivocal. It is happening, it is occurring, and we're seeing a lot of the effects, both in terms of storm frequency, storm severity, changes in water patterns, obviously changes in temperature. So all these are occurring. But what are the drivers to this? We talk about carbon dioxide, okay? But the reality is other significant drivers include methane. They include black carbon. By the way, if I move my cursor over the screen over here, can you see me moving the cursor?
Yes,
Okay,
sir.
good. Perfect. Good. So we see CO2, obviously the major driver. But the second and third most important drivers are methane and black carbon. Similarly, we have other species such as carbon monoxide, hydrocarbons, NOx. You know, all of these are very important. Okay, so we have these other effects over there. Now, when we talk about CO2, you know, it comes from the combustion of fossil fuels. But similarly, so does black carbon. The major source of black carbon, of course, is combustion. Okay, so anything that is going to address CO2 emissions through combustion is going to address black carbon. So we see, and similarly, NOx, CO, hydrocarbons, all of those occur, for example, when you're dealing with combustion sources. Now, the third issue we have, of course, is air pollution and impacts. And, you know, we've all seen the, you know, World Health, report, you know, the WHO report. This is a nice graphic, I think, that shows it a little better. It's a little dated over here. It's from the 2012 data, but you know, things really haven't changed. What we find is air pollution is one of the major causes of death in the world. Okay, roughly 1 in 8 deaths worldwide can be attributable to air pollution. Very significant in China and India, both in terms of the indoor and the outdoor levels that we have. So that's another factor that occurs, you know, that we need to consider. And again, where do these air pollutants come from? They come from combustion, generally combustion of fossil fuels. That is one of the not the only source. We do have other sources, but it is one of the major sources of pollution. So if you go back over here, you know, black carbon is part of particulate matter that leads to, again, the health effects that lead to the excess deaths. And when we look at this over here, again, we see sulfur dioxide coming from the power sector, oxides of nitrogen coming from industry. Transport, you know, is responsible for a significant amount of PM. So, and carbon monoxide, of course. We see all of these different pollutants. And the fourth issue that we often forget about is water use. When we're looking at thermal electric, you know, power generation, we need water for cooling. You have a coal-fired power plant, you're using a lot of water. Okay, very significant source. So in the United States, for example, approximately 40% of the total water use in the United States was used for power generation. Okay, that's obviously a major source of that. And the irony here is we use more water for power than any other sector, and we also use more power for water. Now, I'm not sure of the situation in India, but I'm sure it's significant. And so when you're talking about, anytime you have electricity, anytime you have power, you're using water. And the availability of clean water is critical. So we have this confluence here. And I apologize for the slide. Can you see this? This is very busy over there. Can you see the slide okay?
Yes, sir.
Okay, good. So we have this confluence of energy security, climate change, pollution, and water availability. And when you look at it, where do we get our power from? Significant sources of coal. This is very true in the US. It's very true in India. Significant sources of coal. But the use of coal for power generation has significant issues, both in terms of, climate, air pollution over here, and the water use. Now, of course, we're talking about things like, over here, when we're talking about this, we're talking about carbon sequestration as being a possibility. But again, that's expensive. We're scaling it up, but I don't know if that's really a solution. In the United States, one of the things we have a lot of is natural gas. But there's concerns with natural gas due to fracking for groundwater and air quality issues. Okay. Nuclear has significant advantages with respect to climate, but it uses a lot of water. I mean, there are other issues related to, the radioactive waste, but let's not forget the water issues. One of the things that occurred, for example, with Fukushima was using, in that case, they were using seawater to cool it. That's why it's located on the ocean. But of course, the need for water was one of the problems there. One of the other issues we have for other nuclear plants is they're often located on rivers. As the climate warms, the water temperature increases, and that then leads to a decreased differential in the temperature required for cooling, and that can lead to other problems. Biofuels are a potential solution in many cases, but again, you've got water competition, you've got land competition, you've got food competition in all of those cases. So, we have many energy resources, but there are often these other issues with respect to climate, pollution, water availability. But one thing to remember, when we look at addressing this, we've got an amazing resource out there in terms of renewable energy potential. If we assume roughly 15 terawatts, and this is somewhat dated, need for energy, we have more than enough with respect to either solar, wind, ocean thermal, all of these things. So between these, we have a significant resource that we can tap. And if we can tap this resource for energy, maybe we can start addressing climate issues along with the water issues and the air quality issues. So what do we see in our trends in electrical capacity over here? This is from the REN 21 report. REN 21, their 2019 global status report. If we look at our energy growth over the past few years, we see a significant increase in the global share from both renewables and hydropower. This is hydropower over here. This is renewables. So that grew over 33% in 2018 and continues to grow at a very significant rate. What we've also seen is countries putting in regulatory and pricing policies. So these are driving a lot of what we have. So even now, you can just see the trend of these increasing over here in terms of both, things like renewable energy portfolio standards. This is very common in the US. So for example, it might say by 2025, you need to have 30% of all your electricity in a state from renewable sources. So we're seeing this at a very localized level. We're also seeing carbon pricing policies starting to creep in. Again, some of these are at the country level, many more are at the local level over there. So all of these are driving, are trying to address climate change through these other policies, through either carbon pricing or through other mechanisms. On the investment side, however, that's been variable. Especially, it'll be interesting to see what happens post-COVID over here with, of course, the downturn in the world economy due to COVID. We'll probably see significant decreases due to that, just like in 2008, we saw significant decreases following the recession there and went up. So you can see it has been going up and down. That's the bad news. The good news is the trends in the cost have been decreasing dramatically over here. So if you look and see this range in here, that's colored sort of pink, this is sort of the range for most fossil fuel related energy generation. And what we're seeing is in going from the period over here to the next period, so roughly a 10-year period, that's really what this change is. This is concentrated solar, you see is roughly, and this is in US metrics, so about 34 cents per kilowatt hour, down, dropping in some cases well within this range, almost like, well, over here, down to about 10 cents per kilowatt hour. So we see dramatic drops in all of these renewables, all of the renewable energy. So this is making it cost competitive. So it's really fascinating when you look at this, that you really see that in many cases, I mean, if you're looking, for example, hydro, of course, is well within the range, but geothermal, you're seeing this range of 5 to 7 cents per kilowatt hour. That's what coal generation costs in the US. So it's competitive with all of these things. So no longer when we start looking at renewable energy, is it a more expensive option? The reality is it's an equal option for what we have in terms of the cost for generation now. So that's no longer a barrier that we face. One thing, of course, to always remember is energy efficiency is still the cheapest thing you can do. There's somebody called Amory Lovins. He teaches at, he runs a think tank in Boulder on energy issues. And he refers to this not as kilowatts, but as megawatts. So negative watts over here for looking at electricity. So let's look at the global energy sources. And this is energy from all cases, electricity, fuels, everything. If you look at it solely with respect to electricity, the renewable energy component is significantly higher. But when you include the transportation sector, it's lower. And what you find here is roughly 10% of the worldwide energy use now. This is all energy, this is worldwide, is due to renewables. And that includes biomass, solar, geothermal, hydro, wind, and biofuels for transport. Okay, so more than nuclear. It surpassed nuclear over here. So it's roughly 10% worldwide. If you're looking solely at electrical generation, it's roughly a third. So the issue, of course, is the fuels for transportation that we have. Now, what are the top countries for installed renewable energy technology? And this is from the NREL 2017 data published in 2019. Interesting here, you see India is fairly significant, both in terms of concentrated solar, wind, and also biomass use. Okay. Number one in many areas of China. The United States is also significant. You see some very interesting ones that maybe you'd be surprised by. So for example, if you're looking at solar PV, Germany, not a country that we think of as being very sunny, is number 4 in the world for total solar PV. Russia, of course, has significant hydropower. Canada also has significant hydropower. What you see in Asia here is the Ring of Fire. So you've got a lot of geothermal in this region over here. So it's, we're seeing broad use across the world. Brazil, of course, is known for its biomass biofuels. So let's look at biomass over here. Biomass we generally use for liquid fuels. Okay, that's the case, for example, especially in Brazil, the United States. We use a tremendous amount of biomass for fuel. And you can see the significant growth where from about 2008 to 2017, we've gone up by over 10 million gallons per year production over that 10-year period. So very, very significant with respect to ethanol. And ethanol is used in petrol. It's often mixed in that way. So for example, in the United States, all petrol has a minimum of 10% ethanol in it. So we're shifting from the petroleum-based to mixture of petroleum plus ethanol. In Brazil, ethanol is often 100% used. Biodiesel more than doubled over that period. And so we're seeing a lot of, diesel production also. So from the biomass sector, we currently have the technology to produce both the, petrol/gasoline and diesel that we need for our fuels. But the application is limited. Again, it's Brazil, the US tend to be the major players there. You really see that in both of these cases. Now, this is some work that we did a few years ago. This looks at the life cycle assessment of biodistillate fuels, because one of the questions comes up is, what's the impact on climate change by using liquid fuels? There's some controversy here. There's controversy, of course, in terms of whether or not you're using fertilizer, you're using other things. The basic point I want to get across from this is all of these studies, if zero means it's basically neutral with respect to current fuels, with some uncertainty, but pretty much all of these studies showed that both renewable diesel and other liquid fuels greatly reduced the CO2 emissions with respect to using the traditional petroleum-based fuels. It should be noted, though, that biomass technologies, there are issues. There are water issues, fertilizer issues. Are we using, for example, like in the United States, we use corn for our ethanol. Is that taking away, is that competition for food? Is it competition for land? Are we destroying, in some cases, like in Brazil, forests to produce crops that could produce biofuels? Is that good? So, and we're seeing major improvements in conversion technology, such as cellulosic ethanol production over here. So there are issues there. It's not perfect. Geothermal is becoming increasingly competitive. The average in 2017 was about 7 cents per kilowatt hour, which of course is competitive with, with biomass. With coal, but we're going down to about 5 cents per kilowatt hour. So where's our geothermal production? U.S. has significant resources for geothermal. Most of that is in the state of California. State of Nevada is number 2. in terms of geothermal production. Other areas that have significant production, of course, include the Philippines, Indonesia, Turkey, Italy. There's one plant in Latorella. This plant produces about 750, well, of the total Italian production, of the 0.8 gigawatts, about 0.75 is from the one plant. It's a huge plant over there. So we see significant geothermal production over here, especially when we start looking at enhanced geothermal systems. This is basically fracking for geothermal. That's another way of increasing the geothermal resource, because the reality is you can't create geothermal. It has to be there. It has to be present. And so that's what you have. And so when we look at this and we look at the resource, there's an enormous resource in place, but it's not like it's transportable. You know, it's physically constrained by, you know, the location over there. Land is not a constraint in this case, which is good. Water use is not a concern, okay? You're not dealing with any exotic materials over here. You can't, however, you can't scale it up. You only have the resource, and that's all you have that's available. It's good that it's 24/7. You don't have any intermittency due to, let's say, changing of sunlight, changing of, you know, variable winds. So it's constant. Costs are good. Life cycle looks good. Delivery is easy enough, so long as you have, you know, so long as you have connected to the grid nearby. So let's look at solar now. Now this is fascinating. I took out the slide. Sorry, I had a slide from from the 2016 to 2017, and the jump in 1 year was amazing in terms of the installed solar capacity. I mean, during that period, China went up about 30% solar capacity in just 1 year. And so when you look at this, you can just see the tremendous amount of production that we have. I mean, China's producing over 131 gigawatts per year due to solar. The US is at 54 gigawatts. So tremendous solar production over here. And you can just see the solar capacity as it's going up, much of which is driven, you know, by the increase in China. But the problem with solar, of course, is it's intermittent. Okay. You know, it's only when the sun is shining are you going to produce it. That's really one of the issues that we have. But still, it is such a major, major resource that it's got tremendous potential in terms of meeting all of our energy needs. So when we look at this, it's got tremendous capacity. There really aren't issues with land use. Water use can be a problem, okay? Not for photovoltaic, you know, but for, you know, for other solar thermal systems. They frequently use water in solar thermal, and so that can be an issue. On the other hand, for materials availability for solar thermal, you don't have materials availability for, you know, PV. You do, because you often, you know, you often have rare earths that are necessary to produce the panels. Scale up in manufacturing, that's been a limit right now, but we are able to scale up. This is the problem with respect to 24/7 solar thermal. Of course, you have the storage capabilities, PV, no nighttime production. Cost, you know, really positive. Life cycle emissions, positive. Payback, it's gotten, you know, if you look at the return on investment, doing fairly well. What about wind? Okay, wind capacity. Now, fascinating here, remember before for solar, China had 131 gigawatt installed solar. They've got 188 gigawatt for wind. The US had 54 gigawatt solar, 89 gigawatt wind. Okay, so tremendous, a lot of installed wind capacity over here. And there's a certain irony with this when you look at this. You know, the United States, you know, we're a large country. We have 50 states. Many things are not done at the federal level. They're done at the state level. When you think of the state of Texas, you think of petroleum, right? That's what we see in the movies. It's all of the petroleum in Texas. That's where most of the wind in the United States is. It's in Texas, of all places. So major resource, just put in all over. Issues here, of course, variable power. You've got capacity factors where you're not fully utilizing what you have. One of the things that you often have to do is look for a fossil fire fast start generators to make up for low differentials over there. And many of the resources are not on land, but are actually offshore. So those are some of the challenges that we have. Again, the primary one being the variability. Energy, of course, way more than we need. Land use is somewhat of a problem. Again, it's often an ecological problem. You've got things like bird kills over there, but we seem to be developing techniques to get away from that. No real water use, materials are available, easy to scale up. Big problem, of course, is the intermittency that we have. Cost is very good, life cycle is good, no real other issues. So very, very significant for what we have. What about hydro? Low energy density, but worldwide, frequently used. The issue we have really with hydro is the resource. You have to have the water availability. You have to have the rivers. You have to have things like snow melt coming into the rivers or rain to drive it. So that's the big problem we have with hydro. So the resource is really very limited. Land use, of course, limited by what's out there. Water use, well, you're really not using the water. I mean, the water's generating electricity, but you're not using it up. Scale up is a problem because it's a limited resource, but 24/7, costs are good, life cycle tends to be good, no other impacts. So how do we get away from many of these problems? The way to get away from it really is with storage. And here's an example of a pumped hydro system in Germany, where really what you do is you use the daytime solar to pump the water up to a reservoir, and at night you let it run back the other way. It runs through the generators, and so that's one very common system that we have. Battery storage is becoming more and more prevalent. You see, we've all heard of Tesla, and we think of Tesla as a car company. Well, really, Tesla's a battery company. That's what they're doing. It's the batteries. The largest Tesla plant happens to be in Nevada, outside of Reno. That's where they produce most of the batteries. Half of the lithium-ion battery production in the world now occurs out of that one plant. One plant. Half the world's lithium-ion battery production. That's how big that plant is. So we're seeing battery becoming effective over here. So between these different storage mechanisms, we have the potential to overcome the limitations, with the variability in wind and with solar. So all of these are critically important in terms of what we have and can help overcome those problems. And here you can see just energy capacity, who's doing it, where it's going, and how it's increased. And you just see this increase in storage capacity. So, from 2007, maybe about 12 megawatt total storage, up now to almost 6,000 in that short period. So where are we going with all of this? By the way, CPP is the Clean Power Plan over there. But if you look at use of liquid fuels, continues to increase. Okay, coal has tended to level off. Natural gas is increasing, primarily due to fracking. The use of renewables is increasing and projected to increase over here. And nuclear is also projected to increase. So our energy demands continue to grow. But with that, we have those environmental impacts that I talked about earlier. We talked about air, the air pollution health impacts. We talked about the climate change impacts. We talked about the water impacts. We have all of those major impacts. But what we've seen, and what I hope to have shown you in all of those slides, is we have a large renewable energy resource, more than enough to cover our energy needs, something that's cost competitive, and most of the generation issues can be addressed. Those storage issues can be addressed. So with all of this, even though we have these energy needs, when you look at those trends and those scenarios, we do have significant potential to address them using renewables. We just have to figure out how to transition from that. So how do we start making that transition? So again, what are the prospects that we have? When we look at the resource availability, it's there to address our energy security. When we look at the health and environmental concerns, those are key drivers. The impact on human health, the climate change impact, the water use impact. All of these are incredibly important, and they can be addressed. We've seen new policies to drive this, and we've seen cost parity. But there are problems. In many cases, we're still subsidizing renewable energy. There's those intermittency issues. Natural gas prices, at least in the United States, are incredibly low. So people are not transitioning to other fuels. And here's one thing, that's also really important. We don't account for the externalities. And externalities are costs that are incurred by using something, but that we don't account for in the price of that material. So for example, when you pay for, a gallon of diesel fuel, are you paying really for the health effects of burning that diesel fuel? Are you paying for the impacts of addressing climate change by using that diesel fuel? You're not. You're not paying those costs directly. So when you buy that liquid fuel, you're not really paying for those impacts. And so that's one of the issues, that we don't account for that. You're not paying for the human health effects. You're not paying for the cost of morbidity and mortality that you have. So all of those things aren't in there. And because they're not in there, we're often not making these changes. So we need to account for that. And when, so for example, when you're talking about climate change, I'm not sure if anybody on, attending is an economist, but when you're talking about climate change, if we start paying for these things now, we don't gain the benefit, but our children and future generations gain the benefit. And so when economists look at this, they say it involves something called discounting. We're paying present dollars for a future benefit. So when you do that, all of a sudden it becomes non-cost effective. That's a problem, because we know we're having these impacts. We're the ones doing it, but we're not accounting for all of this. And of course, in many countries, the US probably being the worst offender, the issue has become politicized, in terms of addressing climate change and the need to use other energy resources. And so that is a problem that we have. So, when we look at these implications with respect to climate change, if we can transition to renewable energy, what's that going to do for us? So going back to this chart over here, we see CO2. Well, we all know that. We're going to see that reduction. But we're going to see the reduction in black carbon. and that's our reduction in particulate matter. We're going to see reduction in the ozone-forming precursors, in the NOx, in the hydrocarbons. We're also going to see reduction in carbon monoxide from the burning of those fuels. So as we transition to other energy sources, we're going to have significant impacts on all of these, because when you look at it, when you looked at everything from the life cycle assessment for the biofuels, factors of 2.5 to 4 times improvement, even though we're still burning liquid fuels because of the biofuels and the way everything goes through the life cycle assessment, major improvements over there. And similarly, when we go to electricity from solar, geothermal, or wind, we're not going to have any of those emissions. So we're going, so we can take those numbers and drop them dramatically over there. And what we see here is carbon dioxide emissions by end-use sectors. So for the non-electric emissions, in other words, liquid fuels, this is our transportation sector. Obviously, we're seeing more and more from electric vehicles, but it still isn't even a dent here. On this number, it's we've got, for this total amount in terms of million metric tons of carbon dioxide, we've got almost 2 million metric tons of carbon dioxide generated from the transportation sector, from liquid fuels, and about 4 million from electrical. So very, very small, but that's increasing. So if we generate more of our electricity from renewable sources, we're going to be able to knock that off also. Similarly, when you look at the industrial sector, you can see how much comes from the non-electric emissions versus the electric. Residential, more electric use. Commercial, more electric use. So you can just see, as we transition to those renewable resources, the impacts we can have. And I took this slide from a presentation given by Kevin Hicks and Richard Mills at the GAP Forum a number of years ago, because this was pretty interesting. This was looking at various scenarios for addressing climate change, different measures that could be taken over here, and sort of bending that curve that we have. So, here's the growth in global temperature. Here's here's assuming we don't do anything, this sort of line that goes up this way. Here's bending that curve if we take CO2 measures. Here's bending the curve if we take methane measures and black carbon. And here's if we take methane, CO2, and black carbon measures, how we can be within that 2 degrees C range over here. And we think of this very often, okay? And we see this type of curve and how we can address things. But what we don't realize when we do this, when we look at the climate change over here, here's the impact of the methane measures, here's the methane and the black carbon. So you can just see how much more of an impact we get from just taking those black carbon measures. Black carbon being a short-lived climate forcer, but again, black carbon is produced by combustion, our energy use. But black carbon is also a major component of particulate matter. And thus, it has a major impact on human health. And so here, for example, if we take these black carbon measures with respect to climate change, we can reduce within, on average here, we can avoid almost 2.5 premature deaths per year worldwide. So we see this air pollution impact that we have, but it has this tremendous climate change impact over here. It's able to give us 0.2 degrees Celsius avoidance change in that. And of course, food security in terms of crop losses. So all of these things. So, you know, when we look at our use, our need for energy, our fuel, everything else that we have over here, and we try to address it, let's not look at it in terms of only addressing climate change, okay? Because often climate change is an abstract function for people to understand. Let's look at it in terms of protecting human health. Let's look at it in terms of food security. Let's look at it in terms of water. All of these can have an issue. You know, it'll be fascinating, for example, you know, a friend of mine working over in Goa, Sharat Gudakunda, you know, has done a lot of measurements in terms of air quality and looking at issues in India. He's been sending me some of the data in Delhi due to what's occurred during COVID and the changes. And it'd really be fascinating to see how that affects premature deaths, how it affects the air quality, and how it affects also climate change, just in the short term. So again, how do we get there? And the traditional sustainability approach has been often to look at these things separate. Look at climate change, you know, look at energy use, look at air quality, and all of this will be sustainable over here. But when we look at things separate like that, we miss out on sort of that integrated approach. You know, we miss out on going and saying, listen, we can get climate change, human health, and food all in one, okay? So when you look at the UN SDGs, which, you know, those are the little colors around here, it's a great way of thinking about it, but it only gets us part of the way there. And so my thinking with this is taking that integrated approach even further, looking at it in terms of trying to address those externalities, you know, looking at sort of an integrated approach for public health, environment, the built environment, and energy, and taking into account all of those costs in one. And if we start doing that, like we're seeing that, you know, we're seeing those market mechanisms. Right now, I no longer live in Reno. I live in New York City, you know, and so you think Wall Street all the time. And when you talk about Wall Street, you talk about a lot of what they call ESG funds, you know, environment, sustainability, and governance. Those types of metrics are becoming very common in the financial sector. You know, I've given this type of presentation to people at Goldman Sachs. I've given these concepts to people at Moody's, the rating agencies. These are what we are starting to do in terms of accounting for these costs. So even if governments aren't really putting in, you know, carbon pricing, cap and trade, we're starting to see that on the financial side. And I think all of these can have a major impact for what we have. So my take-home message here is that when we start looking at renewable energy, when we start looking at these energy sources, they can provide our energy needs. And they can do this while addressing our, you know, climate change issues, our human health issues, our water issues. You know, we've got more than enough resource there, but we just need to overcome these barriers. But I think we're close. So thank you for listening to me. And let me stop sharing and see if I can make the screen bigger and start addressing any questions that you may have.
Yes, sir.
Okay.
Thank you, sir. Thank you very much for your wonderful presentation. Now the session is open for discussion. Dear participants, please interact with the professor. Thank you.
Okay.
Hello, sir. Good morning. This is Sindhu from Madurai Kamaraj University, and it was an excellent presentation, sir. I have learned a lot from you. I have a question to ask to you. From what I can understand, the widespread use of renewable energy has been constrained by storage and delivery of it. And from my understanding, apart from lithium-ion and lithium polymer high energy density batteries,
Whoops, I'm
From-
not, I didn't catch exactly what you were saying.
Oh, okay, so I can repeat it.
Yeah, there's a little bit of, I'm getting a little bit of, the sound's not that clear.
Okay,
Can you-
so I'll repeat my question. From my understanding, the delivery of renewable energy has been constrained by storage and delivery of it. I mean, the widespread usage of renewable energy has been constrained by, from my understanding, it's been
Well, it's both
constrained.
storage and that intermittency.
Yeah,
But that's
yeah,
what you
yes, so my question is, apart from lithium ion and lithium polymer batteries, is there any other technology that is in development to store much more, store and deliver renewable energy in a much more efficient way?
Oh, that's a good question. I think a lot of the push really has been on, things like the battery storage and the new battery technologies, because what that does is that allows you to have very distributed solar. So, again, if you go back to the German case, they don't have utility scale solar. Most of that is distributed solar, like at individual homes over there. And so what you're seeing now is battery storage in homes for that. So you're seeing battery storage on that side. You're also starting to see sort of large scale, almost like shipping crate size batteries for storage, because those costs have come down so much that seems to be where things are shifting, which surprised me. A few years ago, I would not have guessed that battery storage is becoming more prevalent. I would have thought pumped hydro, because it's so, it's a relatively simple technology to do a pumped hydro. It's almost like, it's like artificially doing, hydropower basically over there. But, the trend really does seem to be the battery storage for now. But I think you're still going to see a mix for what you have.
Thank you.
So, but yeah, those are pushing it in that direction quite a bit. So thank you for the question. Other
Any other
questions?
questions?
Hello, sir.
Good evening.
Sir, you told us that the climate change leads to premature death. Sir, my
Well-
question is that have you studied the data about is there any? Sir, it is related to sex factor, like more female deaths or the more male deaths.
Okay. Good. Very good question over there. I haven't studied it. I haven't looked into the WHO data over there. And for this over here, I wasn't really saying that climate change led to the death, but it was like the use of fuel that causes climate change also causes death. So you have the two of them over there. Now, when you look at the deaths attributed to our use of fuel, that included both indoor and outdoor exposure. And there was more death attributable to indoor exposure due to outdoor exposure. And the indoor exposure is frequently due to cooking. And if you're looking at traditional cooking methods like stoves or small either wood burning or coal burning stoves that you may see in many homes, especially in rural areas, in that case, I would guess that probably women are more exposed than men, because men are not necessarily inside the house cooking. So there may be some differential, but I haven't looked at it. But I think that's a very good question, and maybe something that could be looked at within the WHO data over there. So yeah, very, very interesting point. But if we can start going to other energy sources like electric stoves, and if those become viable, then of course that would reduce the indoor air quality, which would then help, help save lives over there. So thank you for that question.
Thank you, sir.
Other questions?
So I have one more question to ask you.
Sure.
Of the available natural resources, renewable resources, renewable energy resource, what do you consider as the best bet to address the future energy generation problem to meet the future demands?
I think it's going to depend a lot upon where you are. So, for example, it's again, if you're dealing with wind resource availability, that's not going to be the same in all places. So I think it's going to be a mix of both, the wind and the solar over there for at least electricity generation for what you have. And then, of course, there's going to be the questions of, do we transition more to electric vehicles? Do we transition to hydrogen vehicles? Or do we use, biofuels? I think we're really starting to see more, as the cost of batteries have come down tremendously. It's amazing what you're seeing for vehicles, in terms of electric vehicle production and integration into the market. So who knows? I mean, I think we may start seeing more and more electric, that may be more and more prominent over there. So I think it's going to be a mix of all of those. And I also think that we're going to see sort of a transition that we have. So maybe our transition could be, as we're going, for example, to phase out coal and replace it with natural gas as we slowly increase the renewables. And there are real advantages to that. I mean, one reason that natural gas is becoming so prevalent, at least in the US, is the availability, but it's also 40% more efficient than coal. So if you're looking, so automatically by going from coal to natural gas, you're reducing your CO2 emissions by 40%. So we're going to have many steps, as we go. It's not going to be all of a sudden a delta function. We're going to go like that. But we're going to, so many coal-fired power plants in the US have shut down. They're not building them back up. What they're putting in is they're putting in what they call, gas peakers. So you're getting gas turbines that are driven by natural gas. And those are perfect, of course, for renewable energy, because when it's one way really to address, that need to load balance that you have. And so, coal, we're seeing a real drop in coal in the US, increase in natural gas. And because the increase in natural gas, we're able to increase both the wind and solar, and not have to deal with the grid stability issues.
Thank you, sir.
So, well, thank you.
Sir?
Yes.
I have a question, sir.
Of course.
Sir, having failed to take up the Kyoto Protocol in managing the greenhouse gases, what is your opinion about pay and pollute concept? Like both developing and underdeveloped countries have to contribute the same amount to mitigate the greenhouse gases. In such case, what's the stand we have to adapt, or what's a neutral way to have a balanced type of situation? What type of judgment we take?
Yeah, I mean, that's a good question. That's sort of out of my area of expertise in terms of addressing that. But It's a question that I would understand, because in a sense, you've got the developed countries, they've already gotten to develop and have the emissions. And then, of course, you have the developing countries who are trying to develop, who are trying to, expand their economies. What can they do? And, the way that I look at it is, we can have those targets, but I think the developed countries have to lead.
Yeah.
They have to do their share.
Yeah.
And that's why, as I say, if we start looking at things like the Kyoto Protocol, like all of the COP meetings and other things like that, these are things that setting these targets, but again, they're only looking at things like the CO2 emissions. And that's what I'm saying. If you start taking more of an integrated approach, and you start saying to these countries over here that, okay, let's not look just at CO2, because they're going to sit and say this is impacting our economy. Let's look at the health effects.
Yeah.
Let's look at those excess debts. Let's look at those healthcare costs. Let's account for that and change that discussion from saying we have to follow these protocols of, if we do this, we're going to be protecting human life.
Yeah.
We're going to be saving money. So it changes that discussion from one country saying, well, we need to do this to grow. You've already grown. It changes. You get caught in that cycle where everybody has a valid point, but nobody's going to agree.
Yeah.
When we start looking at these other things and looking at these other mechanisms, then that changes that whole discussion. It makes that choice about protecting human lives.
Yeah.
Makes that choice about having water for agriculture, or for food security.
Yeah.
So looking at it that way, and of course, as our costs for the renewables go down in terms of energy generation, then that also makes it a lot easier.
Yeah.
Then it's like, okay, if the costs are basically the same, why not go with the cleaner alternative if it's going to save you money in the long run?
Yeah.
So that's, I think once we start getting into that discussion, like following the Kyoto protocols, then those barriers come up, and those political barriers come up, and we're unable to address the problem. And so that's my point, looking at this integrated approach, and maybe that could give us the solution. So, but very important question, and one of the things that we face all the time.
Yeah.
So thank you.
Sir. Thank you.
Hello, sir. I have a question for you from Ruchika Sinha. I'll paraphrase the question for you. So, how fast can we switch from classic non-renewable energy to renewable energy to slow down the global warming process and to keep up with policy targets? I'll repeat the question again. How fast can we switch from classic non-renewable energy to renewable energy as to slow down the global warming process and to keep up with policy targets?
Yeah. So if you look at how fast can we switch to renewable energy, it's I guess I could sit down and do those calculations, but when you look at things like the renewable portfolio standards, which are targets within the US, boy, we can switch probably over a 20, we can switch half our power to renewable within about a 15-year period. That's in the US case. So, we can make significant strides there. But again, it's going to depend on the country. It's going to depend upon, what they want to do. And one way to do it is as old plants phase out, if you can look at it in terms of trying to get most of your growth due to renewable, and then as old plants phase out, putting in new plants that are renewable, it's going to vary. But I would, I'd have to really go and look at those numbers, but I think it can be done in a reasonable time period. But that's not a very good answer to the question, but I really haven't tried to work that one out. But when I look and see the amount of change, it can be done within the next, a 20-year period is doable.
Thank you, sir.
Okay.
Dear participants, please interact with the Alan sir. If you want, you can post in chat box. He will ask on behalf of you.
Okay. Let's see, where's the chat box?
Yes, sir.
Okay.
Sir, there is no response.
Oh, wait, let me look here.
Yes, sir.
Okay, so
Sir, there is no response from the participants, so we can thank Dr. Alan for his excellent presentation.
okay.
Thank you, sir. Thank you
Thank
very
you,
much.
everybody.
We will
Okay.
invite you for some other classes also, sir. Thank you, sir. Thank you very much.
Okay, take care. Have a
Thank
good
you, sir.
evening. Okay.
Have a nice day, sir.
Okay.
That's very interesting. ಒಂದು 10 ಮಣಿಗೆ ಇವರು ಅಪಾಯಿಂಟ್.
Dear participants, thank you for attending the session. Our tomorrow session begins at 10 a.m. sharp. Please be available at the same time and please be ready at least 5 to 10 minutes before the start of the session. And if you have any more query, you can direct it directly to Professor Alan. And please take your time to fill out the feedback form after the end of the session. Thank you and have a good night. See you tomorrow.